Well, good morning, everybody. My name is Gene Bohensky at Exothermic Molding. Welcome to our webinar presentation today. Today we'll be going over 3D printing for prototyping and production of large parts with a comparison with reaction injection molding. So in this presentation, we're going to start with an introduction to exothermic molding. Then we'll go into what 3D printing is, what reaction injection molding is. Then we'll go over a comparison of the two. And then at the end, we'll go over a little bit about our services and what makes us unique as a company. So let's get started. So this year is our 50th anniversary. So we were founded in 1971 with a business plan to provide reaction injection molded RIM parts, as they're called, to the medical, electronic, and lab instrument markets, which we still serve primarily. Our headquarters is in Kenilworth, New Jersey, and there at right is a picture of our facility where we do our manufacturing today. As a company, we're committed to innovation. We continually make investments in technology, equipment, and in our employees so that we're at the forefront of our technology and manufacturing prowess in order to serve our customers. Our mission is to provide the highest value reaction injection molding and 3D printing services available. So our core competences, basically number one is the ability to produce large complex parts using RIM or 3D printing techniques. Our primary market is for equipment companies where we make their enclosures. They're very complicated enclosures and complicated parts. And that's what we've focused on and what we're successful with. We produce tooling in-house for fast development time, fast time to production to help our customers get to market quicker. We have a particular concentration on providing high quality finishing services as required by a demanding customer base. That's really what we do well. For low volume production items, we provide our customer parts faster, with a better finish, and at a lower cost. So what is 3D printing? So 3D printing, also known as additive manufacturing, the parts are produced layer by layer. 3D printing is growing in popularity as costs decline, especially for large parts. Materials include plastics, PLA, polylactic acid, PET, or ABS. You can also use powders. Some 3D printers use powdered materials to construct products. Metals, carbon fiber, and other new materials are being used as 3D printing continues to develop. We focus on large format fused deposition modeling with a 1 cubic meter size, which at this point covers a lot of our customer requirements. We also have a partnership with a company that has an even larger 3D printing equipment for larger parts if necessary. One of the things that's very popular about 3D printing is because of its fast time to market and ability to bypass the need for tooling, it's particularly well suited for prototyping. So what is reaction injection molding? Reaction injection molding is a unique process using the reaction of two liquid thermosetting polymers. One of the things that it has, it's an advantage, is a lower mold cost, which is ideal for low volume complex parts. So it produces strong, lightweight parts suitable for painting, and it's extremely cost effective for specific applications when compared with standard injection molding. And you have a safe encapsulation of electronics due to low molding temperature. And this is one of its real pluses because whenever you have injection molding, you have very high temperatures, high mold temperatures, and high plastic temperatures, and electronics can get destroyed during that process. So when we compare the two, RIM versus 3D printing, the primary advantage of 3D printing is that parts are printed on demand, speeding the development process and eliminating upfront tooling costs. That's the primary reason people are using it, because you can visualize in reality, bring your part into reality much faster and do testing on it, test concepts and see whether the part is really what you need. What is also happening, though, is that 3D printing is actually becoming used more often for low volume production, and even in some smaller parts, even a medium-sized production in the thousands of units. But even for large parts, that like the type we usually get involved with, 3D printing can now be used. So one of the issues, though, is that you have layers that adhere together. Although they adhere together, they can delaminate under certain stresses or orientations. And you have additional post-processing that is required for quality surface finishes. And also materials availability can limit applications. However, one of the things we want to point out, and we'll show you in this presentation, is that we have the ability to do that post-processing to allow 3D printed parts to have the same type of quality that our standard or our rim parts have. So with rim, with our new Proxima material, our Proxima material availability offers superior mechanical and chemical resistance properties. You can have stronger and tougher parts. Also the ability to encapsulate electronics, like I mentioned before. It's easier to get superior surface finishes, and you also have design freedom similar to 3D printing. Let's go into this picture here that really illustrates what you can do with 3D printing. So on the left here, we actually have one of our customer parts. On the left, that part is made with our standard rim process. And on the right, the identical part is made with 3D printing. And here at the right section of the slide, we have two pictures that really show, really from the back side, how these parts are made. So you can see a little bit about how the 3D printing process works with the layers here, that you can see the layered plastic. You can also see the inserts that have been molded into the unit, just like you can do with rim molding. On the bottom right, there is the same part that is shown from the inside, showing how you can basically add all the different type of design features, ribs, encapsulated parts, any type of structural features you could also easily make with the 3D printing process. So what we're showing here is that for the type of enclosures, for prototypes, that the 3D printing process really can yield the same level of quality of parts as our rim process can. And specifically, our internal finishing capabilities can make sure that those parts come out exactly the same. So for the customer, they don't see that it's a 3D printed part, which is where you want to go. I want to talk a little bit about Proxima. Proxima is a groundbreaking advanced polymer technology based on DCPD, the dicyclopentadiene materials that are now commonly found in the marketplace. The Proxima thermosets differentiate themselves from the other DCPD materials in that their unique characteristics are developed through a polymerization reaction enabled by the proprietary Grubbs catalyst technology. That's a Nobel Prize winning technology, which is unique to Proxima in comparison with other DCPD materials. This unique catalyst technology produces a finished material with greater cross-linking between the polymer chains, resulting in a stronger and tougher material. It also allows for a process that is much cleaner than the standard DCPDs. You don't get the same type of off-gassing or just the other chemicals that come off that process. With this process, the end parts don't smell, don't have the same type of outgassing issues that other DCPDs do. So there's some benefits there, as well as the superior mechanical properties. This slide will go over a couple of those. The Proxima material does have exceptional toughness, high impact strength, and resistance to crack propagation. The parts are basically unbreakable. They're lightweight. They have excellent hot-wet properties, extremely low water absorption of polyolefins compared with the thermal stability of thermosets, as opposed to polyurethanes, which have some much higher water absorption. And they also have a low carbon footprint. Cradle-to-grave emissions are 47% lower than epoxy resins. And they also have low viscosity resins, which allow the quick molding of complex shapes. Again, one of the benefits of the rim process is to mold complex shapes with different wall thicknesses. And it's really, rim is the ideal process. Really, when you're starting out with your product design, you can start out with 3D printing. You can get those parts quicker for your verification and validation stages in your product design. Then for the first couple of orders for low volume parts, they can be 3D printed. But once you get to a certain point, when the volume is a little higher, the rim process is ideal as the next step as this product becomes more popular in the marketplace and you have more volume. So from our standpoint, 3D printing really fits in to the marketplace, really, as it helps our customers speed up their development cycle and get those products to market faster with parts that can be made pretty much on demand, even large parts. And with our finishing capabilities, they're going to look like the same parts as they would be when you're making them in large production. Let's go a little bit through some of the applications. We can show some other pictures that we have made of our parts. Our typical customers or typical applications are housings and covers for medical device, laboratory, and scientific equipment, structural components with a high quality finish requirement. You can see some of the pictures here. Go through some of them. Here's some more of our parts. Any of these parts can be 3D printed as well as rim molded. Though I think the one in the top there is very big. That might go beyond the size of the 3D printers available today. The Proxima material itself has materials strengths where it's even possible to be used as a wheel, and this wheel is undergoing testing, undergoing certification testing. So it's really the material itself has properties that are better than what could have been or what is normally found with rim processes. Let's look at some more of our capabilities. Here you can see our machining center where we make our own tooling. We can assist you from design concept to final production, including mold making. We have an area in our facility where we do sanding of the parts to make sure that any of the imperfections are taken off. We also have a whole section for painting where we offer an automotive grade finish for our painting. And final finishing, where the last stage is to make sure those parts look perfect. So at this point, I want to open the presentation up for questions. If you have any application questions, we have some experts on the live here that can answer any of your questions. Does any of you have a project that you are working on?
I have a quick question.
Sure.
You offer 3D scanning as well?
This is Paul speaking. We don't have 3D scanning in-house, but we have resources that can do that.
Okay.
Paul Steck is the owner of Exothermic Molding and is the application's really expert. So he can answer any of your questions regarding.
Okay. When you scan them, it goes into like a SolidWorks format?
Yeah, it does. It goes to like a point cloud formation, and it can then be we've scanned items and then made molds from the scans, from the data that comes off the scan. So exactly what format is used depends on the CNC machining center, but I guess the answer to your question is yes, you can take the data from a scanned part and use it to create a solid model, and then you can create the mold off the solid model.
Right, right. And you can do any modifications in the works programming, correct?
That's right. In the solid model, it'd be SolidWorks or something similar.
Sure. Okay, that's really all I need to know.
Yeah, we would add, normally you'd have to add shrinkage or something like that if you wanted to
Absolutely.
get an on-size part. Yep.
Yep, I get it. Just wanted to see if that was one of your capabilities. Thank
Yeah,
you.
we've done it in the past.
Fantastic. Thank you.
Thank you.
Does anyone else have a project that they're working on or questions that they have to ask Paul or myself?
Hi guys. Who builds tooling for the rim process?
Well, we have an in-house machine shop, and we also use other mold building shops. We control the design process, and then we can send out molds to be built by multiple shops if we're not going to do it in-house. So if we've had programs where we've had to build 8 molds in 6 weeks, and we bring in multiple shops to do that, and you just have to plan ahead for it. But yeah, that's how it goes.
Okay. Can you give us an approximate size envelope that works well for rim molding?
I would say most of our parts are with footprint of a square foot, 12 by 12 and up. We find that if something's going to be maybe 6 inches by 6 inches, it might be more cost effective to make an aluminum injection mold and injection mold those parts and then paint them, especially if they're with other larger rim parts. But that's just a general rule of thumb, not always, but in general.
Okay. What about a max size? Because you were talking about large parts, and I do work on things that have big parts. So a lot of times you're doing structural foam and that type of end product, but it would be really nice to get big prototype parts or even early production. I don't have a sense of how fast the process is or how strong it is.
We've made parts that are molds that are 10 feet long, and we've molded parts that weigh 30 pounds. So in general, a part that's 2 feet by 2 feet is sort of a average large size part for us. We've made parts that are much larger. And in terms of the lead time for something like that, typically it would, if it's just one mold, we would just quote with a typical lead time of 6 to 8 weeks, and we would say, or as required. If you need it sooner, we could talk about that. The lead time to print a large part, let's say that would be 2 feet by 2 feet by 2 feet. I would say, once it's all organized and laid out and we have everything aligned, it would take probably a week to get it printed, with shipment, if it needed to be shipped into us, and then another week to do the finishing. Or as required, it could be done faster also.
Cool. Maybe last question and I'll quit hogging. How fast is the process? So not the tooling side, but actually making parts. I mean, if you were doing, say, your 2 foot by 2 foot by 2 foot box or whatever, can you get 1 part per day, or is it 100 parts per day, or what?
We can make it. We typically make about 50 parts per day per mold. So that gives you maybe a cycle time of 10 minutes to make a part in a rim mold in a press. So you could do maybe 6 per hour, roughly.
Great, thank you.
You're very welcome.
Good morning. This is Dan Fermack. I have a quick question. We saw
Okay.
some time. How are you guys, what variables are you guys looking at to decide when to use 3D printing and when to use reactive injection molding?
And that's a really good question. Wow. I mean, you just have to you have to work through the numbers and run the numbers. You have to do a quote. If you're only going to be buying, 10 parts a year, you don't want to make a mold. If you're going to be building 25 parts a month, you want to make a mold for sure. And somewhere in between there, you have to you decide what your amortization and how your company amortizes, what they want to get, what they want their payback for tooling to be. So I would say it's probably, after you're going to be printing 10 parts, you're going to start thinking about a mold, and then, seeing where your market goes with that. If your market's going to get up to 10 a month, then you're going to want to have a mold probably.
Maybe as a follow-up to that, Paul, what kind of limitations are you guys experiencing on the material side, or what are your limiting constraints for 3D printing materials today?
Well, I mean, certainly, the materials, obviously, if we're making molded parts out of this Proxima material that you can hit them with a sledgehammer, or, you can drive over them, with a car, and they don't break, they'll move around a little bit and twist, but you're not going to get that as easily with a printed part. And, with an FDM part, you're going to have your layering and the resultant layer to layer weaknesses, unless you get into a heated enclosure. And it all depends on the technology of the machine that you're using.
What materials, maybe a better question is then, what materials do you guys print with today?
Like the most common, material would be like an ABS, which is most similar to, the urethane or the DCPD in terms of, we'll call it flex modulus and stiffness. And the parts that you print, you want to be able to, if you want to get a good finish on them, you have to be able to sand them. So think, nylons and some of these Ultem harder materials are more difficult to sand, typically. And that's really a big part of it.
Thank you.
Okay.
Does anybody else have any questions?
If anybody ever wants to have more information from us, we're always happy to do budgetary quotes and discuss designs, and there's no cost for any of that stuff. We're happy to try to point you in the right direction for what would be optimum, the way to make your product.
Right, on the last slide, we have the email of our inside salesperson, Virginia@exothermic.com. If you have any questions, you can send your inquiries or information there. We'll be happy to provide more information. Okay, I do see some other questions in a chat room. One person asked, how much would it cost to make a coffee mug? Can we do something like a coffee mug in RIM? Or
if it's depending on a coffee mug to rim mold would be roughly a $5,000 mold, and a painted part would be $20, and it's certainly not the most cost-effective way to make a coffee mug. You'd want to injection mold it, where you could make a plastic coffee cup mug for maybe 25 cents, and you wouldn't need to paint it.
okay. Anybody else have any questions? Well, thank you for your attendance, and thank you. Have your names, so we'll be in touch.
Thanks, Gene.
Thanks, Paul. Thank you, everybody.